Alright guys, this is exam 2 review for the spring. Let's get started. Sketch the resulting plot if you enter the MATLAB command plot b, comma a, comma single quotes o. Let's write out what our b is. Let's say b is equal to -2, 1, and 2. A is equal to 2, -1, and 4. That's an equal sign, I'm sorry. And then we're going to match these values up and plot them. So 2 and 1, I'm sorry, -2 and 2, 1 and -1, 2 and 4. Come over here, you could draw a Cartesian plane, although it's not going to be plotted as a Cartesian plane. It's alright. You say b is -2, 2. We're going to plot that with a circle, that's important. You see over here on plot, it has single quotes O. And that's all I'm really looking for when I grade. We have 1 and -1 here, and we have 2 and 4 here. And if you want, you could label these points -2, 2, 2, 4, and 1, -1. So let's go over to MATLAB and see how it runs. I'm going to run this section, then I'm going to run this plot. And you see it plots. However, it doesn't have the Cartesian planes here. I'm not going to take off points for that. What I do want to make sure you guys know is, had I said, let me say close all. Had I said plot b, a, single quotes, let's say I have a dotted line in there and I have a triangle pointing to the left, where its point is pointing to the left. And let's say I have the color, blue. I don't know. I'm winging it, guys. I'm winging it. You need to know what these symbols mean. And if you turn to page 157 in your textbook, you have table 5.2 line mark and color options. For problem number 2, write the function header only for the function that has 2 output arguments, the distance and velocity, and 1 input argument, the time. The function name projectile. Alright, so I'd come over here, get my piece of paper, I'd say, I'd write the function header first. Our function header starts off with the word function. Next is our square brackets. These are our outputs. Set equal to the name of the function, and then in parentheses are inputs. And so the way that we would write this, let me get some more space on here. The way that we would write this is we would say function, our output would be d and v for distance and velocity, and our name would be projectile. I'm just going to say project because I'm running out of space, and our input would be t. That's how you would do that one. Let me give you a quick example of a function header. You have the word function. I'm not going to have any outputs. I'm going to set it equal to my function name, which is going to be my name. And if you're following along, you could use your name. But if you still use my name, that's pretty cool. I'm just going to have it display hello world. I'm going to end my function. And you know what? Let's kill 2 birds with 1 stone. Let's jump over to part 4, what 2 commands allow a function to finish processing. I come here, I could say end, and I could save it as mark. I could come over here. Did I run this for you? I don't think I did. Hey, there's your triangles and your dots. Sorry. I could say mark, and it's going to print out hello world. However, I could also come back here and say return, and I'm going to save it, come over here and say mark, and still prints out hello world. So for this problem, what two commands allow function finish processing is going to be return and it's going to be end. Either one of these would work. Cool. So on question number 3, what is the exact output when you enter the MATLAB command w is equal to x of find of y, where squiggling the line equals mean does not equal to 140. So we find where y doesn't equal to 140 and we write those numbers down. Y doesn't equal to 140 at position 1, at position 3, at position 5, at position 6. And over here you see this position 1, position 3, position 5, and position 6. So now we're left with x of position 1, 3, 5, and 6. And as we remember from our previous exam, we were pulling values out of a matrix by position number. So we take the first position in x, we set that equal to w. We say it's going to be position 2. The third position is 1. The fifth position is 10. And the sixth position is 12. And let me just highlight this. This is position 1, position 3, position 5, and position 6. So if we come over here to problem 3, we run it, we see that we get 2, 1, 10, and 12, which 2, 1, 10, and 12. You got to make sure it says w equals as well. W equals. Problem number 5. Using valid MATLAB commands and using the plot command, plot the tangent function for the values between negative pi over 2 and pi over 2 incremented by pi over 100. So would come over here and would say that x is equal to negative pi divided by 2 colon pi divided by 100 colon pi divided by 2. I would say y is equal to the tangent of x. And then we just say plot plot x comma y. And that's how we would do that part. Remember, these colon operators are from exam 1. We're not using tan d because these are radians, and this is our plot command, plot x comma y. And if you come over here to MATLAB, you see I said from negative pi over 2 by pi over 100 to pi divided by 2, y1 is equal to tan x1, plot x1, y1. The reason why I have x1 and y1 here is because I don't want to get confused with x and y up here. I run it, and it warned me about fplot, but I threw in an fplot down here to show you that there's an easier way to plot the tangent. You can see here these are the same graphs, nearly the same. This is the first one, which the sharp edge right here. This is the actual f plot, and it's nice and rounded. So problem number 6: if x is greater than true, greater than 2, display true, else display false. And let's see what the value of x is equal to. That's not what I wanted to do. And what we need to remember here is that for every value in x, it must meet this criteria down here. And so for the first value is 2 greater than 2. Here's what I would say. I would say 2 greater than 2. It's either going to send a 0 or 1. It sends a 0. That means it does not display true. It skips this and it displays false. So on this line right here, what will be displayed, we're going to write false. Let's check that to make sure. It doesn't say false, that says place. False. Okie dokie. If any C is less than or equal to 5, or D is greater than 7, display true, else display false. Let's see what the value of C is. C is 5, so C is equal to 5. And since this is an OR, it doesn't matter if this one is a 1 or if this one's a 1. But let's just see, is D greater than 7? No, it's a 0. So this is sending out a 1, this is sending out a 0. In Boolean algebra, when you say OR, you're basically saying if one of you are a 1, then we're good to go. So C greater than or equal to 5, or D greater than 7. This is sending out a 1. This is sending out a 0. 1 ORed with 0 is 1, which means that the if statement is true, and it would execute the following line of code, which is display true. So the answer is true. And if we go back to check it, we come over here, I could run this section, and you can see that's true. Let's go on to the next one. So if E is equal to C, if 5 is equal to 5, and, which means they both have to be true in Boolean algebra, and A is greater than or equal to B. Well, here we got to go element by element. So here's A, and that's equal to 2, -1, and 4. And then B is equal to -2, 1, and 2. And I would write this down, guys. Might as well. You have nothing to lose. And if you mess up, at least you showed your work. You might get partial credit. We say A is greater than or equal to B. We're comparing them by position. So is 2 greater than or equal to -2? That's true. Is -1 greater than or equal to 1? No. This is where our problem is. And you're only as strong as your weakest link. So that whole if statement is going to send to 0, which means that we go to the else statement and we execute that code. And what's going to be displayed is false. And let's go check that on MATLAB just in case. False. Good. How many times will the following loop execute? We know that for for loops, they just execute for however many columns there are in the indexing matrix. And our indexing matrix is usually denoted as I. So just this top line right here, for I is equal to 1 through the length of Z plus 1, that's given us all the information that we need to figure out how many times it's going to loop. So the first thing that I would do is I would find out what the length of Z is. And the length of Z, we come over here, we just find the largest dimension, 1, 2, 3, 4, 5. The length of Z is equal to 5. And then I is equal to 1 by 1 to 5 plus 1. That's equal to 1 through 6, which means that there are 6 columns. 6 calls. And so how many times will it loop is the same amount as there are columns. So the answer should equal to 6. And if we come over here to the MATLAB code, I prove this to you by using a counter. Let me run this section. You see that it counts from 1 all the way up to 6. This is the first time, second time, third time, fourth time, fifth time it loops. And it ends on the 6th loop. So It's looping 6 times. Guys, I would like to apologize. I was about to move on and I noticed this line right here, string to num of G. The problem is G isn't a string, it's a double. So that's an error. And then I looked closer and fprintf I, x. I mean, that's not really an error, it's just not going to display what they want them to. So that's this is definitely an error though, and the problem is that it's not going to run at all. So the correct answer is 0, and Steve got me. See, that doesn't run at all. Well, I guess it executes one time. It doesn't finish though, because it never hits the end. It just has an error in the middle. So I would say 0, or would it be 1? No, I'd say 0. I'd say it doesn't execute. There's an error. Let's had it have been normal, 6 would have been correct. Let's go on to the next one. So it says, while f is less than x of 6, display f plus 1. So we're adding 1 to f until it's until that condition is no longer true. So f is 12 right now, and x of 6 is 1, 2, 3, 4, 5, 6. F of 6 is 12 as well. I'm sorry, x of 6 is 12 as well. So what we end up getting is 12 less than 12, and that's going to send to 0, which means the while loop doesn't execute. It just skips on to the next line. So how many times will the following loop execute? Is the answer is 0. And if I come over here, I could show you as 12 less than 12, it's going to return a logical 0. And that's all the while loop does, is return either a 1 or a 0. It's 12 less than 87. It's going to be 1. Same thing with an if statement, guys. When you're using these conditional operators, it's either going to return a 0 or a 1. And so over here, there we go, sorry. It won't run at all. I think a good way to check that is x is equal to, oh no, don't use x. DFSA is equal to 12. If it goes through the loop, make DFSA equal to DSFA. I don't know why I chose this. Plus df plus 1. So I'm adding 1 to that value. And then afterwards, please display DFSA. So here you'll see that it's equal to 12, and we should just get 12, 12 popping out. And we do, which means that this loop didn't execute at all. Let's go on to the next one, problem 11. So complete the for loop below so that it will print out the value 0, 1, 4, 9, 16 and put them in the variable p. We see that 0, 1, 4, 9, 16 is just I squared. And the way to put it in variable p is to build the matrix out. So we'd say p of something is equal to I squared. However, what do we put right here? Well, if we set x equal to 0 up here, we put p of x right there, and right before p of x, we put x is equal to x plus 1. Now, every time that it runs, the first time that it runs is going to be p of 1 is equal to I squared, and I is going to be equal to 0. And so the second time that it runs, it's going to be p of 2 is equal to, and then I is now going to be equal to 1, And every time it loops, I is going to change the value. So the first time that it loops, it's going to be I is equal to 0. What's I equal to on the last time that it loops? It's equal to 4. And x will be equal to 5. And so if we build this out, we should get the values 0, 1, 4, 9, and 16. Let's see if that's true. So I'm going to run this section, and 0, 1, 4, 9, and 16. Good. And it printed out twice because I didn't suppress it here. And then I displayed it here. Okie dokie. So on problem 12, what is the exact output when the command displayed the value is num to string b? Well, we come over here and we can see that b is equal to -2, 1, and 2. And then we come back over here to question 12 and we make sure this is the correct format. And it is. It's the correct format. Num to string. This is a number that we're converting to a string. You have to use square brackets. There's single quotes around the characters. So this is going to work. And let's write the answer. The answer should be, the value is -2, 1, and 2. So that should be what's displayed. Let's check to make sure that's correct. We come over here, minimize this. Just CLC this really quick. For problem 12, we see that the value is -2, 1, and 2. So for problem 13, what we're going to do is first we're going to find x of 3 through 5, and then we're going to find semicolon y of 5 through end. And we're going to build this matrix. That's all this is a matrix. So x is going to be from 3 through 5. Over here you see x is x of 3. So this is 1, 2, 3. It's going to be 1, 8. 1, 2, 3, 4, 5. It's going to be 1, 8, and 10. And then y of 5 through end is, let's count it. 1, 2, 3, 4, 5 is 160, 110, and 140. 160, 110, and 140. That's the matrix here. And then we're just going to display this. DISP. And so what prints out is 1, 8, and 10, 160, 110, and 140. Let's check to make sure that's correct. Index exceeds matrix dimension. It's actually not true. I gotta run this section again because I redefined x right here in problem 12. Problem 11, I'm sorry. So I come back to problem 13 and I run the section and it's 1, 8, 10, 160, 110, 140. 1, 8, 10, 160, 110, 140. I'm sorry that my handwriting is so messy, guys. I apologize. Problem 14. fprintf. %.0f is the first value and %.2f is the second value. Line feed G. And what is the exact output when this is entered? Well, let's figure out what G is. G is the matrix 2 and -3. So in problem 14, you have .0f, percent .0f, which means it's just going to be a 2 with no values after the decimal place. And then you're going to have the words is the first value, and then you have percent .2f, and that's going to be -3 with 2 places after the decimal. And then it's going to continue. I could have wrote the words here, but squiggly lines is going to do. So all that the TAs are looking for is that you know that there's this value is going to be 2, this value is going to be -3, this value does not have any zeros afterwards, and this value has 2 zeros afterwards. That's what they're looking for. So no values, 2 values, 2, -3. And let's go on. What is the exact output when the command fprintf a is equal to percent .3f, b is equal to percent .2f line feed, and we're going from 2 through end with a comma, b 1 and 2. Well, let's figure out this matrix first. Oh no. Let's figure out this matrix first. So what's a of 2 through end? That's a -1 and 4. And b of 1 and 2 is -2 and 1. So the matrix that they're building is 2 through end, -1 and 4, comma 1 and 2, b of 1 and 2, which is -2 and 1. So now when we call fprintf, percent .0f, blah blah blah, what's happening is every time that it runs across percent .0f or percent .2f, well, here it's percent .3f and percent .2f. It's going to be calling from the position. So the first time it hits the percent f, it's going to grab the first position. The second time it hits, it grabs the second position. Then if there's still a matrix left over, it's going to grab the third and the fourth. So the answer should be -1.000, and this is words, then this is words, and then it's going to be 4.00, and right here it's going to be words, and then -2.000, and then some more words, and then 1.00. Right, just 2. These 3 zeros represent the 3 places after the decimal shown here, and these 2 zeros represent the 2 decimal places right here. And when we look at this value right here is, I could turn that into an A. It's saying a is equal to -1 and a is equal to -2. Well, when we come up here, a is not equal to -1 and a is not equal to -2. B is not equal to 4 and B is not equal to 1, except right here. So you see it's out of order, it's not lining up. And when you see this on your test, it's going to be a little confusing, but you just got to know to do this matrix correctly. I should show you the proof. So we have -1, 4, -2, 1. These 3 zeros represent 0.3. These 2 zeros represent the 0.2. And you can see on the side, A does not equal to -1 and -2, and B does not equal to 4 and 1. So something's wrong there. If we draw out our matrix, let's see, we're going to have fprintf single quotes, we have percent 0.0f. I'm going to use an ampersand sign. Percent 0.2 f line feed. And then here is our matrix that we have to figure out. Right here. We'll put our matrix right here. And so A of 2 through 3 is going to be -1, -1, and 4. -1, 4. And B of 1 and 2, where's my cursor? B of 1 and 2 is -2 and 1. Don't be confused that it puts 1 by 1 to 2. It's the same thing as saying 1 to 2. And I said it was -2 and 1. And so the way that's going to get called out is -1 is going to come first. We're going to have an ampersand sign, and there's nothing after the decimal place. Here we have 2 values after the decimal place, and since we don't have values specified, it's just going to be -2.00. Remember, this is pulling out by position. This is position 1, position 2, position 3, and position 4 inside of this matrix. And this is what's printing out. Here we're going to have 4 ampersand and then 1. And that's going to be 1.00. So let's check to make sure that we have that correct. We'll come over here, and that was problem 16. We want to run that section. We have -1 and -2.00. We have 4 and 1.00. -1, 4, -2, 1. That is that's the same. Perfect. Now we are going to move on to the next section of finding all the errors. And this is going to be fun. So let's get back to finding the errors. I think the best bet is to just start reading. All comments in this part of the exam are correct. Code should match the comments. You get 1 point for finding the error and 1 point for correcting it. This function will approximate the value of the cosine function using a series. Okay. The function has no output arguments and 2 input arguments, one for the number of terms n and the other for the radian value x. So the function has no output arguments. That's what I see. I see that we have an output for s. And so I would just delete that. Also down here, you see that we don't have anything ending a function. So I would put return or end. No, return. But I want it to line up. I would say that's 2. I would count that as 2. One for the number of terms n and the other for the radian value x. And I remember we have to make sure it's radians. So we found 1. There's 2 for not putting in return. Check to see if the number of terms is at least 1 in the program. If it is not, right here, we're not checking to see if it's at least 0. It's checking to see that's at least 1. Well, check to see if the number of terms is at least 1 in the program. If not, so then less than or equal to. We're going to say at least 1, which means that it could be greater than 1. So we want this. If n is at the minimum value 1 or greater. Oh, hold on, I see what he's doing. Display invalid. So we want to say if it's less than 1, display invalid number of terms. I was doing it differently, where if this condition was true, execute the for loop. He's saying, I see what he did. I'm sorry. So we'd say 1. End. Return. Return end. Execute a loop to calculate all the terms of the series. For k is equal to 1 through n. We wouldn't start at 0. The reason we wouldn't start at 0 is because if I have 5 terms here and I go from 0 to 5, k is going to be equal to 6. So really I'm calculating 6 terms, and that's not what we wanted. S of k is equal to this. Sums is equal to s. That's right. It's not wrong. I just don't know why. I mean, you could have it in there. It's not going to hurt anything. I don't know why he has it in there though. Let's keep on going. Display the number of terms, the approximation, and the actual value of the cosine of x. Display the number of terms, which is n, number string n, and n is a double, so that's good. The approximation, the cosine is sum of s. This is the approximation. And the actual value, and we have the actual value right here. So this looks right all the way up till here. He threw in an extra single quote, but other than that, that looks right. And then num string of x is, and we have num here. And I think that's it. So we had 1, 2, 3. Is that all we did in for loop? 3. 4, 5, 6. That's 6, but I feel like I'm missing one and I can't see it. Let's count it over here. It's easier to see. Here's 1, 2, 3. 4, 5, num 6, and then return 7. Yeah, so this should work. Let me CLC. Yeah, I'll clear it. CLC, and then run it, and it's going to save as a prox cosine. Not enough input arguments. Oh no, that's true. So let's say 5, and what is the value of the cosine of pi divided by, let's just say pi. Using 5 terms, the cosine is negative 0.97602, and the value of cosine is 3.1416 is negative 1. That's true. So it works. It runs. So here's my function. I just copy and pasted it into MATLAB, and I should actually save it. Save it as energy. And I'm going to dock it here. I'll throw this to the other side. So question 17, what is the name of the function? Well, we come over here to the function header where it has its outputs, its name, and its inputs, and we see that the name of the function is energy. How many input variables are there, and if any exist, give their names. How many input? Alright, so we have 2 input, we have mass and C. 19, how many output variables are there, if any exist, and give their names? Our outputs are M total and E. If you entered the command ME is equal to energy 3, 2, what is the result? Alright. So, number 20, if you entered the command ME is equal to energy 3, 2, what's the result? Would get that mass is equal to 3. Mass is equal to 3, and C is equal to 2. And so we'd come to our first if statement. If the sum of the size of 2 is not equal to 2, display invalid. Well, the size of this is just going to be a 1 by 1, which this isn't going to exist. It's just going to be 1, 1. And then we could take the sum of 1, 1, and that is equal to 2. So we're good there. And if any mass is less than 0, and mass is 3, so it's not, we're just going to skip that now. M total is equal to the sum of the mass. So M underscore total is equal to the sum of the mass, which is 3. And E is equal to MC squared, where E is equal to M 3 times C squared, which is 4. E is equal to 12. And so we pass that up to our function, our output, and we had initially named it ME. And the two values that we're getting out are 3 and 12. I don't know if you could actually do that in MATLAB, but that's how I think about it, where 3 goes to M and E goes to 12. And so our first answer should be M is equal to 3, E is equal to 12. M is equal to 3, E is equal to 12. And so we come over here, and we say M comma E is equal to energy of, that's 3 comma 2, I think. 3 comma 2. M is equal to 3, E is equal to 12. Good. And let me just point this out really quick. Had we switched these variables to E comma M, the first one out is always going to be M total, no matter what you assign the name to be. So even though we switch the names here, E is going to be equal to 3 and M is going to be equal to 12. That's important. And if that seems confusing, well, you can name these values whatever you want. They're just random values. You can name them apples and bananas. I named it gifts of digits. So, you know I'm serious. Alright, let's keep on going. If you enter the command in MATLAB, ME is equal to energy 310 and 2, what is the result? Well, you come up here again, and we know that the mass coming in is equal to 3, 1, and 0. That's a matrix. And then we know that C is equal to 2 again. And so we check this if statement. If the size of 2 is not equal to 2, well, it is. This is a 1 by 1 again. And the sum of the matrix 1 comma 1 is equal to 2. So we're good. It bypasses this. If any mass is less than 0. If any mass, is mass less than 0 here? No, mass is 0, but it's not less than 0. So we're good there. It bypasses this. That means M total is equal to the sum of the mass. So that's just 4. M underscore total is equal to 4. And E is equal to M total times MC squared, and C is 2. And so it's going to be 4 and 16. And if we come over here, we can just change these values to 3, 1, and 0. I believe that. And 2. And I said it was going to be 4 and 16. M is equal to 4, E is equal to 16. Actually, I said M total is 4 and E is 16, and that's wrong. I would have docked myself points for that. Because this should just be M. I wouldn't dock you guys points for that. I mean, I should, but since I messed up, I can't dock you guys points. That'd be messed up. If you enter the MATLAB command, if you enter the MATLAB command, ME is equal to energy of 0, 6.2, 5.0, negative 1.3, and 4.9. What is the result? Well, I would like to do all the calculations, but the sum of the size of C is not equal to 2. The sum of the size of the C is, it would be 1, 2, 3, 4 by 1 would be 5. Sum of the size of C would equal to 5, and this right here would not execute. And so what's going to return? Well, if we come over to the notepad, we could see that it's going to say invalid speed of light. We have our matrix M, and that's going to be an empty matrix or an open bracket, and E is also going to be an open bracket. And so that's what should return. And if I come over here, I could copy this, slide right, paste, and we see invalid speed of light. M is an empty bracket, E is an empty matrix as well. And we're good to go. Let's do it again. If you enter the command ME is equal to energy negative 2, 8, 5, well, they mess up on two parts. We have mass, which is less than 0, and we have C, which is not equal to 2. It's equal to 3. And so again, it's going to say invalid speed of light. M is equal to an empty matrix. E is equal to an empty matrix. And let me copy and paste this to show you. Invalid speed of light. M is equal to empty matrix. E is equal to an empty matrix. Let's go on to 24. If you enter the command E is equal to energy 112, 2, what is the result? Well, let's come over here and start working it out. We have mass equaling 112. We have C equaling 2. These two if statements are going to be, where's my mouse? These two if statements are going to be okay. And so we come down here and we hit up M total and E. So we see M total is equal to the sum of the mass, which is 4. C is equal to M total times C squared, or MC squared. 4 times 4, sorry, C squared is 4, times 4 is 16. And this is E. E is equal to 16. And then when it outputs, your mass is going to be equal to 4, and your, M total is equal to 4, and your E is equal to 6. I just wrote that. Oh, it's late. 416. But down here it says E is equal to energy, and the first value out is M total. And so here, the final answer is going to be E is equal to 4. This is the E inside the function. I have the word function up here, and then I have this big square. This is just what's being displayed. So I didn't want to confuse you with this E and this E. This E belongs to this part right here. And this E comes from setting it equal to E, but it's going to be M total. So I predict that it'll be equal to 4. Let's see what happens. Throw it over here. Say E equals, hey, E, what the heck? E is equal to energy right here, and our prediction was E is equal to 4. E is equal to 4. Let's keep on going. We got 1 left. M is equal to energy 1, 1. We see that the size is 2. The mass is greater than 1. M total is equal to 1. 1 times 1 is 1, and we get M is equal to 1. Is that the right one? Yeah. That's it. M is equal to 1. That's what comes out. We have now finished problem 25, and we'll be moving on to problems 26, 27, 28, and 29. And then I'm going to do these codes really fast and we'll be done. So here it is. I just copied and pasted it. And it's showing up as, well, let me save it. Save as triangle 2. What is the function's name? The function name is triangle 2. That's what we named it. How many input variables are there? If any exist, give their name. There are no input variables. How many output variables are there? If any exist, give their names. There are no output variables. What is the output if you enter MATLAB command help triangle 2? The output is the first line that's commented after function. It's really just reserved for this first line after the function header. So if I commented down here, it wouldn't show up when I say help triangle 2. And let's say help triangle 2. Say plot the triangle with random vertices, values between 0 and 10 only. That's cool. Let's see what happens if we run it. What? Why? Oh, because I can't run it like that. You gotta say triangle 2. Oh, that's cool. Oh man, those get me every time. Every time. Alright guys, now we're getting to the good stuff, the coding. I'm not going to be flipping to this page anymore. I'm just going to stay on this one. I am going to open up an editor and undock it. I shouldn't have clapped that loud, sorry. Oh, let's get ready to go. Weird. Using these equations, create a function using the following steps. Note that on this problem you are only writing the code to find the answer. Steve throws an egg at disgraced TA Mark's house from a distance of 64 feet, and Steve is 6 feet tall. He throws the egg with the initial velocity of 60 feet per second and at an angle of 30 degrees. How far up on the wall of the house will the egg land? You'll need to use the following equation to find the final height, where g is equal to 32.2 feet per second squared. This is worth 9 points. Define the header of the function with h0 and v0, initial height and velocity as input arguments. Not use an input command with the output argument, the height on the wall where the egg lands. Ask the user to enter the angle theta of the egg that is thrown. Calculate the velocities vx, vy using the first two equations. Then find the delta t and delta y. Note that delta x is defined as 64 feet. Finally, find the height where all the on the wall where the egg lands, delta y plus h naught. Some specific values in bold in the problem statements are not used in the program. Oh man, that is... Wow, that's serious. And that hurt when I read it. Mostly because he egged my house. That's mean. That's mean. Okay. Let's get started. Define the header of the function. Define the header of the function with h naught and v naught initial height velocity as the input arguments. I could put h0, v0. Well, that's vo. As the input arguments, not using the input command. With the output argument, the height on the wall where the egg lands. The height, what are we going to call that? The height on the wall where the egg lands. Wall height. That's too much typing. Wall height. Ask the user to enter the angle theta of the egg that is thrown. Theta is equal to input enter the angle that the egg is thrown. I'm doing this live, guys. This is how long it takes me to do a function usually. I have to sit and read it 8 times to make sure I know I'm doing it right. Calculate the velocities Vx and Vy using the first 2 equations. Okay. So Vx is equal to V naught times the cosine of theta Vy is equal to V naught times the sine of theta. Steve uses degrees up here, so I feel like we should stick to degrees. Yep, that seems appropriate. Calculate the velocities. I just did that using the equations. Then find the delta t. Oh, here's where we gotta use some algebra. Oh man, I wasn't ready to do that. Hold on. So the way we solve for delta t is this on? Yeah. So we come over here. He gives us a hint. He says delta x is defined as 64 feet. You see over here, Steve throws an egg at Disgrace T's Mark's house from a distance of 64 feet. So if we come over here, we know that delta x is equal to Vx times delta t. Quick algebra, we say delta t is equal to delta x divided by Vx. That's going to be our equation. And somewhere at the top we should have delta x is equal to 64. So when we come over here, dx is equal to 64. We could say dt is equal to Vx times dx. Perfect. I must press this. that. I'm going to suppress that. And I'm going to suppress that. And I'm going to put return. And the only reason it's not showing up is I haven't given it a name yet. I was hoping he'd tell me what to write. Then find delta t and delta y. So after we have delta t done, we come over here to this equation. We have delta y is equal to vy delta t plus 1/2 g delta t squared. And he gives us g, 32.2 feet per second. And so that's another constant. G is equal to 32.2. And that's feet per second squared, of course. And I'm actually going to put dx up here, 64 feet. dt is equal to vx times dx. I'm going to come down here and do delta y. dy is equal to vy times dt. And plus 1/2 at squared. We don't use a, we use g times dt. And finally find the height of where the wall I'm sorry, that was weird. Finally find the height of where on the wall the egg will land. Delta y plus h naught. Some specific values in bold in the problem statements are not used in the program. I don't know if that's right. Define a header of the function where h naught and v naught, the initial height and velocity as input arguments, not using input command, with the output arguments, the height on the wall where the egg lands. Well, I think h naught would be 6 feet tall. Well, I mean, everybody throw something really quick. When you release, you release right at about head level. Hold on, let me stand up. Maybe right above, so, I'm going to say it's 6 feet. But we're entering in h naught. I would have said that was a constant, but we could say that WH is equal to h naught plus dy. And I'm going to name my function. I'm going to give Steve a shout out. That's for you, Steve. That's for you, Steve. And then I'm going to run this. Well, I'm going to save it. So what I really want to see is, does Steve hit my house? Steve is 6 feet tall. And I could just say 6 because we're going feet per second squared for G. And the angle that he throws it at is, the initial velocity is 60 feet per second. Which is about, was it like 40 miles an hour? I think it's 40 miles an hour. It's about 40 miles an hour. And the angle that he throws it at is 30 degrees. I haven't done the math yet, but... Oh, he... I don't know how tall my house is. But I might have made a mistake on this, because it's saying that he's hitting my house at I guess I have a really tall house. Oh, I know where I went wrong. I'm sorry, I lied to you guys. This is negative. G should be negative. That's the gravitational pull towards Earth. Oops. What am I saying? He misses. Sucker. I might have coded this wrong. I'm gonna pause it. I'm gonna make sure that everything's good. Guys, I did mess up. I don't know why I did that. I'm sorry. I had here delta x divided by vx. Delta x divided by vx is delta t. I'm gonna check this one more time too. Hold on. And alright guys. So if I come over here and say that he's 6 feet tall, he throws an angle of 30 degrees at 40 miles an hour, which is 60 feet per second. He hits my house at 18 feet. I felt god awful coding that. I was egging my own house. That's how I feel. But we'll go to another one. A cone-shaped paper cup is designed to have a volume of 250 cubic centimeters. Right. Write a function that determines the radius r of the base and the surface area s of the paper for cups with varying heights that will be the input arguments for the function. The equation for the volume and the surface area of the cone of v is equal to 1/3 pi r squared to h, and s is equal to pi r square root r squared plus h squared. The function will have two output arguments, the radius and the surface area, and one input argument, the height, which will be the scalar or row vector only. I read that and I still don't know what's going on. I'm just going to start with my function header. I've reached that point in the night. I'm hoping to get this posted tonight. I hope. The function will have two output arguments, the radius and the surface area, and one input argument, the height in which h. Oh, I need to name this. Let's give a shout out to Charlie. That's my dog. Like, not like, oh, that's my friend. No, that's my dog, Charlie. She stays up with me while I do homework and stuff. She's a good girl. Yep. What am I talking about? Write a function that determines the radius r of the base and the surface area s. I've read this so many times. Of the paper cups with varying heights that will be the input argument of the function. The equations for the volume and surface area are v is equal to v is equal to 1/3 times pi times r squared times h. S is equal to pi times r times sqrt of r squared plus h squared. I know, guys. I gotta do algebra. I'm just writing the equations down. Now I'm gonna say end. So here we need to solve for r, and we have h, and v is a constant. It's 250. So I can say v is equal to 250. And I'm gonna go to this side and solve for r. Pen and pad. V is equal to 1/3 pi r squared h. Throw everything to the other side. 3v divided by pi h. 3 pi h is equal to r squared. R is equal to the square root of 3v divided by pi h. That's what I got. R is equal to SQRT of 3 times v divided by pi times h, where I need this to be in the denominator. And h is going to be entered in as a scalar, so this is going to be dot divide. And just for safekeeping, I can say dot times. I can say dot times here. I could throw dots everywhere. Well, I mean, I shouldn't. But if you guys get confused and you don't know where a dot goes, yeah, just throw it in. Usually it's right, but you might be wrong. But we're not doing matrix division or matrix multiplication yet, so I'm pretty sure you're right if you do that. And that was this equation that we used. And so now we have to solve for the surface area, and we don't have to solve for the surface area. We have r, we have h, pi. We're good to go. But we do have to make sure that we could do matrix multiplication and division. I mean scalar multiplication and division. R is a constant, but since h is going to be a row vector, that means r is going to be a row vector, so I have to put this also. And that means that this is going to be a row vector, which means I have to say dot times. I don't have to say dot times here, but I'm going to throw it in just in case. And I named this one Charlie. Yeah. Giving shout outs. So let's, did I call Charlie yet? No. Say Charlie, and the height is going to be 2, 3, 4, 5, and 6. That looks right. It feels right. Okie dokie. Let's go on to the next one. That's what I meant. $32. Alright, let's open up another editor. Create a function. So I'm just going to put the function template up there. And he wants me to call it mph. I should put an M there. mph 2fps. Define the header of the function which does not return any values. So this is going to be an empty matrix. And has one input argument. The input argument will be a row vector values in units of miles per hour. So I'm going to put mph here. And correctly convert the miles per hour values to feet per second. So 0.681818 mph per FPS. And so I should go over to this side. Correctly convert the MPH values to feet per second. So I know that's 0.681818 mph to feet per second. Correctly convert mph to feet per second, so I'd flip that. So in my code, I want FPS is equal to mph divided by 0.681818. That's because here it's let me go down here. I have 0.681818 mph, and it's FPS is equal to 1 FPS, and I multiplied this by whatever mph was coming in. That means this mph and this mph is going to cancel, and you just get left with FPS. So I'm gonna come over here and I'm gonna say I just wrote this too. Feet per second is equal to mph divided by 0.681818. And using display command, print the values of these two vectors in column format, where mph is in the first column and FPS is in the second column. So then what we say is display, and he wants mph to be in the first column, and then he wants you know what, this is a safer bet. Print the values of these two vectors in column format, where mph is in the first column and FPS is in the second column. Is it a comma? Yeah, it is. FPS. That's right. And what these do, the colons, is it puts it all into one long column. That way we're good to go. Using the fprintf command, print the values as blank mph is blank FPS on separate lines. You should print the mph value to 2 decimal places and the FPS to 3 decimal places. Oh my goodness, Steve. So fprintf, set it up, get your basic template going. And he wants %f mph, and I'll go back in and fill everything in. %f FPS. I'm just putting it into a basic format. This is going to be mph, and this is going to be FPS. And then I come back. You should print the mph values to 2 decimal places. So I just say 0.2, and the FPS to 3 decimal places. So I say 0.3, and that's it. That's all. That's all we had to do. Return and save as mph to FPS. And I hope I did it right. mph to FPS. What was the one before? Oh man. I know, guys. This is my screen right now. It's a new computer. Just got it today. I'm really excited. What did he say? He said 60 feet per second, and I said that was 40 miles an hour, right? I think I believe that to be true. And so I'm going to enter 40 miles an hour, and I think it's going to be 60. .40 miles per hour is about 58.667. Yeah, I was wrong. I'll own it. I was wrong. But I messed up right here. Oh, no, I just didn't suppress that. So save it. And I should put a \n right here. Because it did ask me for on separate lines. So I guess I would have been counted off for that. Well, I should have been. I hope I have a cool TA. Let's see. What is 60? I'm gonna say it's 41. No, I'm gonna say 40. .5. Then we'll try 41. .40 miles an hour is 58.667. 40.5 is 59.40. 41 is 60.133. Yep. So I think it might be more accurate to say 60 feet per second is 41 miles an hour. I was wrong. Given the function header, write the function that calculates. Given the function header, did he give it? Oh, he did. Given the function header, write a function that calculates the value of the equation 2 times the square root of x squared minus 1 divided by x, where x is the input variable, can be a row vector of values. Note the denominator cannot have a value of x is equal to 0, and the numerator cannot be between -1 and 1, not inclusive. Also keep in mind that a row vector of values could be sent to the function. So if x is either 2, 1/2, 3 and 4, 4, 0, 5, or -3, -1/2 and 2, then an error message must appear. No calculations will be performed. However, the following values would be okay: 1, -1, 2, 4, -4, etc. Oh man, last one, dude. You got this. You got this. I hope my mic is on. What if my mic was off this whole time? Don't jinx yourself, man. Don't jinx it. Function value is equal to func32. That's a weird one. I want to do my own name. I'll come back and figure out what I want to do. Where x is the input variable, can be a row vector of values. Note the denominator cannot have a value of x is equal to 0. So that's my first one. If x is equal to 0, return. Well, I should display an error. Does he ask me to? So if x is either, then an error message must appear. Okay. So display error and return. And if x is, note the denominator cannot have an x value of 0, the numerator cannot be between -1 and 1, because then it would be imaginary. That's what's up. So if x is less than, if x is less than 1 and x is greater than -1, it would be an AND function, or an AND logic. gate. That goes to -1. So if x is less than 1, what I'm saying is if x is between -1 and 1, then it also has to be an error. Display error. Return. And otherwise the output value, that's not how you spell value. Value is equal to 2 times sqrt of x squared minus 1 divided by x. And this is the numerator. And what if x comes in as a matrix, which it's supposed to? And since it's coming in as a matrix, I need to say any. If any. And I'm going to call this one... Who am I going to give a shout out to? Shout out to my brother. That felt good. I'm glad I did that. Return. Yeah, no, I like my brother. Oh. Did I mess up? I don't know if I messed up. I don't want to commit yet. Nah, dude, I'm good. I'm good. You're overthinking it. And let's run it. Let's run it. Every time I call my brother, I'm like, broski. That's what I say every time. Bartholomew. Broseph. We just think of different things. Yeah. Broden. That's Caden. But with... That's bro plus Caden. Broden. That's that time of my error. I got an error. Good. And it said I should get an error on 4, 0, and 5. 4, 0, and 5. I also get an error. And I should get an error on -3, -1/2, and 2. -3, -1/2, and 2. And I don't think I hit the negative sign. -3, -1/2, and 2. Why did you do that? Error. And this calculation should be correct. The 1, -1, 2, 4, -4. Got him. Now let's just hope my mic is on. Guys, I want to wish you all the best of luck for your upcoming tests. And I'll see you soon.